Okay, so Blessing still quarantine until 20 November, and 27 will be after that. After 27, we'll be able to come to the university, right? And how about the other? How about Jordan? You're in quarantine, right, Jordan? How about the other who are in quarantine now? Kenzie, you also quarantine or no? Okay. But have you booked your flight, Maria? Have you booked your flight? Okay. How about the other? Kenzie, beginning of December. Okay. How about Kenzie? Kenzie, you still quarantine or not yet? But Jordan, you finish your quarantine, Jordan? Okay, so Scarlett, yeah. Okay. So Kenzie and Jordan, you guys already finished, right? Your quarantine and your self health management, right? Okay. Yeah. Okay. And Jonathan will be will you already have uh booked your flight? Have you booked your flight, Jonathan? Okay. Okay. So 24 is already booked. Okay. Okay. Actually, today I will go uh, to a new chapter, the the chapter 5 in the textbook. Okay. Now we will move to a new chapter. So about the exponent and log, uh, I already give the assignment. I've checked, and I think most of you done a really good job. And uh, we will have another quiz. Okay, another quiz, online quiz. Uh, the estimate uh, schedule will be around from maybe from tomorrow, from tomorrow until maybe until 22. Okay, so you can choose to work out the quiz between this time, and I will make announcement tomorrow. Okay, so after tomorrow class, I will make an announcement. Check the Google Classroom. Okay, check the Google Classroom. The topics will include the exponent and log. Okay, including how to solve the inequality, the log functions, most of what we have done in your uh, assignment, also in our class. Okay, so we will have the quiz, probably around 20 questions, 15 to 20. Okay? Now I'm in progress making the quiz, and yeah, maybe around this number. Okay. And if you take the quiz too late, okay, maybe you take. I will make announcement like how like maybe the announcement until so 4 p.m. is maybe the last or the deadline. If you're doing the quiz, maybe the quiz needs around 30 to 40 minutes, and you click the quiz maybe around 3:50, and at 4 p.m. you haven't finished yet, but the quiz will stop, and with the quiz will stop, and the empty answer will be just leave as unattempted. So, for example, you already done 10 from 20. So your point is only 10, and it's not all correct, right? Okay. So be careful on doing this. Okay. So I already make announcement like several times, also in your calculus class. Uh, some students, I think, take the quiz really well before the deadline, but some are taking uh, close by the deadline. So several questions is not answered. Okay, so I already make several announcements about this. Remind you guys all the time. Every time in the class we will have quiz. Don't forget to take the quiz. But you still make this an answer not answering the quiz because the deadline is overdue. So please look at the schedule. Mark in your calendar. You have smartphone. You have laptop, right? And I believe there is a calendar, and you can make some marks on your calendars. So you can just open your smartphone, go to your settings for the calendar, and check in these dates, and make sure you got to take the quiz. Okay. Okay. Yes, Scarlett. The one that I just emailed to all of you about the last quiz. You can check the PDF file. I think I already emailed to your GApps account. I already emailed the last quiz. So that last quiz, I have all the your answer, and then what is the correct answer and which one is your mistake. Okay, but I think last time several students make some it's correct answer, but it's wrong form. So I make an adjustment, and I correct that your answer, so that will be uh, your results will be different from the final results. Okay? Your quiz result will be different from the final because I make an adjustment. I check your answers once more time. So yeah, and the final results will be actually higher because I've adjusted your answer. Okay. Okay, so that's the quiz. Okay, because why you cannot take after the for example, if you take the quiz after this deadline, and you talk to me, oh, I want to take the quiz because I forget blah blah blah. The problem is not that I can give you the quiz directly, because the settings on the platform, because it was designed to make sure that all the students will be working on the scheduled time. So if I want to reopen, it couldn't. It couldn't because as a system, we already done that. So I need to rework, design one more time from the scratch, and I will not doing that. Okay, I will not doing that. So I cannot reopen the quiz. Okay, so that's the problem. So I think 17 to 22 is it's I think it's quite a long time, right? 17 to 22. It's not like 17 and 18 that you need to go between those two. So 17, 22 is 5 days around. 6 days. It's 6 days, so should be enough, right? Okay. All right. Okay, so exponent and log, that's the quiz. We will go through the trigonometric now. The title will be so this will be trigonometric functions. The first sections, so there will be a 3 chapter about trigonometry. The first chapter is about the unit circle. Okay, so we start by looking at the circle. We have learned that the equation for the circle, if we take this x axis and y axis, okay, if this is 0 and the radius is 1, okay, we take the circle formula as x squared plus y squared equal 1. Okay, so this means that unit circle is the circle of radius 1 centered at origin in xy plane. So if we want to check, okay, for example, if we check the point, uh, this point here, based on the formula, okay, so if we check the formula for the circle, this will become 3 over 9 plus 6 over 9. This will be 9 over 9. All this will be 1. So we, from the formula here, we can say that P is on the circle, on the unit circle. Okay. Okay. Also, we need to learn that we have 4 quadrants. Okay. This is quadrant 1, quadrant 2, quadrant 3. If we divide the circle, become 4 a region, and this will be quadrant 4. Okay. So if we have, for example, we have P, another point, square root of 3 over 2, and then there will be some y. Okay. It says that this P is okay on unit circle, quadrant 4. And then we can find the y coordinates. Okay. So we can just adjusting the point with the formula. And we got this is 1 over 4. So y is plus minus half. But since it is on quadrant 4, then y is negative. Okay, I think for the introduction, this is I think you're already familiar with the circle or the unit circle. Okay. Okay. Now we move to another point in this unit circle. It's called the terminal points. So suppose we have t that is a real number, and we start with the circle. Okay, so we will start from moving a point along the unit circle. Okay, the one to start is, so if this is x-axis, this is y-axis. So we will start from this 1, 0 point here, and we say that if we move along like that, okay, maybe until here. Maybe I just make this. Okay, and let's say that that is the we move a point. Okay, this t is a positive. Okay, okay. Remember, if you have a circle and you move counterclockwise, okay, that means the uh, it's regards as a positive movement. Okay, and let's say that we have a p, a point xy there. Okay, if we move clockwise, let's say moving here, this means that t is negative. So this t is actually uh, what we call a terminal point, or uh, I think it's better to include the point. So the p obtained, p obtained is called terminal point that determined by real number t. So if you look at the circle here, to measure the t, how much it is, okay, we'll measure through the angles, okay. So let me draw another circle to illustrate. Okay, so for example, from this one, okay, 1, 0, I will move the point along the circle until this 0, 1. Okay. How to move? I will move like that, and as you can see, this one a circle divided by 4. The angle will be a 90-degree, right? So this t will be pi/2. Okay. And you can also uh, use that definitions to, for example, taking this, let's say, the green one from the original point until here. This will be t equal pi. If you make a full circle, so this is a full circle, and going back to the original point, so we will have a full circle 2 pi. Okay. And of course, every time you are moving the point, you will get a different coordinates, right? So for example, this one you get um, -1, 0. You get here is 0, -1, and you got here back again. It's uh, 0, 0, 1, 0. And when you move clockwise, okay, when you move clockwise, for example, from here going to here, okay, this t will be -pi/2. Okay. Okay. Now, what you need to remember from this measurement, that you always start from the point 1, 0. And this is always your this will be your always your starting point. Starting point. So in a unit circle, if you want to move around, then you need to start from 1, 0. Okay. And if we look at uh, the terminal point on a special value of trigonometric, okay, so if we check with t, start from 0, and then pi/6, pi/4, pi/3, and pi/2. We will have several terminal points. Of course, we start from 1, 0. Okay, start with t0. So of course, 1, 0 is also, you can say that we start from x squared plus y squared, right? Equal 1. Okay. So we start from 1 plus 0 is 1. Okay. That's based on the circle formula. Okay, the second one here is if we are moving 30-degree, right? What will happen here? This will have special value. Okay, if you remember, and if you move pi over 4, it will have symmetric divide the circle precisely, and this will have this, and the pi over 2 will be have that. If you look at the circle, so we start from here, this 1, 0, and then let's say this is square root of 2. Should be around here. This also should be around here. And this will be half, and this will be 0, 1. Okay. Okay. We haven't yet touched the trigonometric. Okay, but you have seen that by using some t and make some movement along the circle, we can have this kind of a special coordinates, right? And maybe you remember that, okay, it's related to sine and cosine, right? Okay, now this is we call a terminal point. Okay, so we move with some degree of t. Okay, so t will be a real number that is in radians, and we will have a terminal point alongside the circle. Okay, now if we have another thing, okay, related to t, we call that as reference number. Okay, assume t is a real number. Reference number, or this is usually write t with a dash on the top, associated with t is the shortest distance along the unit circle between a terminal point determined by t and x-axis. Okay, perhaps it will be better if I draw what it means. Okay. If we start, let me make copy. So if we start from this point here, okay, start from 1, 0. We are moving maybe through here, okay, through this t. The reference number is just the same as the t, okay. If we move this t from here, maybe until here, okay. So this is the t, okay. So maybe it's greater than pi over 2, right? So our t will be, the reference number will be here, okay. So this is suggesting that you will see that the movement is basically the same as, if you have this as your angle here, basically we can say that this is movement based on this angle here, this t, reference t. So we are going to have a shortest distance with the between terminal point and the x-axis. Okay. And if we have, for example, another one, maybe we move the t until here. Okay, this is t. Then our t will be here. The reference number t will be this one. You see the angle here, and that will be the angle. So actually, the value for the angle will be similar value. The difference is the signs, okay, whether it's positive, negative. Okay. Like for example, if this part here, okay, if this is equal to 5/6 pi, then this reference number is actually pi over 6. Okay. So we are just focused on the value of this short distance here, okay? Because later we are going to make a specific value for the trigonometric based on this pi over 6, pi over 3, pi over 4, pi over 2, okay? So that's the basic on a unit circle reference number. Okay? Okay, what's happened when you have t is equal to 29/6 pi? What's happened with the terminal point? Okay. Now, if we look at this, okay, we look at this, we see that this 29/6 is actually we can divide this, and we see that it's actually becomes 4 pi plus 5/6 pi, and it will be similar to what we have in this point here, and this will be uh, negative 3/2.5. Okay, so if you know the t and you know how to express in terms of uh, the uh, the the pi or the angle, then you can find, so it means that because 2 pi is 1 per circle, so 4 pi is twice. So it will go around twice and then go around for a 5/6. Okay. Okay, I think that will be the first introduction to the unit circle. And I think it's still very basic. We haven't touched the trigonometric yet. Okay. Okay. Any questions? I think no, right? It's still introductions. Not really that complicated, right? Okay, any questions? Or maybe Arjun? No? Okay. Yeah, I think this is just the intro. Okay, the other sections in chapter 5 is we are going to take the trigonometric functions, okay, of real numbers. Okay, of real numbers. We are focusing on real numbers. Okay, now we are define our trigonometric value. Okay, remember that we move from the point 10 here, and we move maybe through here. Let's say this is having xy coordinate, okay, and we call this is t, okay. Okay, so we move a distance t along the unit circle from starting point 10, and we move uh, counterclockwise. So that will be a positive, and we can also move clockwise, which is makes the t negative. And we know now we are using the xy coordinate to determine what it is. Okay. Okay. Let me write the directly definitions of trigonometric functions. Okay. Let t be any real number, and let the p xy, the coordinate p, be the terminal points on unit circle determined by t. Okay. We determine sine t as y. We determine the cosine t as x. And we define the tangent as y over x. Of course, we have the complementary for the sine is cosecant, will be 1 over y. Y should not be 0. We will have a secant. Sometimes it's also called a circular function. So trig functions, also called a circular functions. Okay. Okay, so let me use the quadrant one, the one that's easy to follow here. So if this is x, y, okay, and we have t, if we look at, okay, if you look at closely, we can always make this into our x, y, okay. Of course, from x, y, we know that sine t will be y. This is radius 1, right? So over 1, okay? This is how we can look more precisely. Our cos t is x over 1, and also tangent t will be y over x. Okay? Or we can make this t is in our angle length, okay? And based on the table that we made before, we know that if we have t pi over 3, the sine will be equal with the terminal point P on y, which is the square root of 3 over 2. Okay, and then cos pi over 3 is the half, right? Okay, and tangent will be square root of 3. And I believe you already know the special value on the trigonometry. Okay, but if something happened, uh, maybe you got nervous on exam, or maybe not really sure how to prove it, you can always go back to the circle unit and check the point. Check the point. For example, this point, when you check, oh, this is makes sense, okay? And we know that this is precisely in between uh, this is precisely here, pi over 4. T is pi over 4. Okay, and then we have also, okay, from this trigonometric value, we can set up the domain for trigonometry. Okay, we can set up the domain. Sine, cosine, this will be, the domain will be real numbers, or all real numbers, right? And tangent, secant, this will be all real numbers except pi over 2 plus n pi for any integer n. because if secant is 1 over cos, 1 over cos pi over 2 will be 1 over 0. This will be undefined. Okay. And the other one is the cotangent and cosecant. This is all a real number except the n pi, the one that makes the bottom equation 0 for any integer n. Okay. Okay. Now remember I talked about the quadrant. Okay. So let me make the quadrant. So this is 1, 2, 3, 4. The order is based on how the t will works. Okay. So t will work from, or will move from 1, 0 here. This will be moving through this. Okay. Moving counterclockwise. Okay. From 1, 2, 3, and 4. So based on this 4 quadrants, we will start to check what will be the signs. Okay? For this one, this is all positive, right? And you see that this is y-axis and x-axis. All x and y number within this quadrant 1, they all have positive, right? So you see, if you remember, sine t is y, and cos t is x. Okay? Okay, so sine t is y, cosine t is x. So all x and y within this xy uh, graph here, they are all positive, right? Okay, so this side will be positive. If you look here, the quadrant 2, y is positive, right? X is negative. Okay, which means sine t is positive, cosine t is negative, right? Okay. This is how, because I remember I learned this quadrant, I think in the high school. I thought that I need to remember this, memorize it, but actually this is how it came from. Okay, you just can see the xy is positive, and then from here you see that sine still positive, cosine negative, because y is positive and x is negative. Okay, and we move here. Okay, we move here. This will be x is negative and y also negative. So sine will be negative, cosine will be negative. Okay, if we include tangent, like from here, from this quadrant 2 also, what happened with tangent? Tangent is sine over cos. So positive divided by negative, so it should be negative, right? Okay. Okay. So sine negative for quadrant 3, sine negative, cosine negative, so tangent will be positive, right? Negative divided negative, it should be a positive sign. Okay. And this right here, the quadrant 4, x is positive, right? Y is negative. So sine is negative because y is negative, right? And cosine will be positive. And tangent, negative divided positive, this will be negative. Okay, easy to follow, right? Okay, so please remember, this is how logically you can think in which quadrant maybe sine is positive, cosine is positive, and tangent is positive. That will be quadrant 1. And if you want to make the possibility for tangent to be positive, it's only in 1 and 3, sine positive in only 1 and 2, cosine is only in 1 and 4. And that's how you make the relations between the quadrants the sines and the trigonometric values. Okay. Of course, if you look at the cosecant, secant, and cotangent, they will all be complementary with the sine, cosine, and tangent. Okay, so you just need to check the sine, cosine, and tangent. Okay. Okay. So based on these quadrants and based on the reference number, okay, different reference number that we already make definitions. If I have, for example, okay, cosine 2 pi over 3. Okay. If we look at this as an angle, for example, 2 pi over 3 is 120, right? Yeah, 120. Of course, it will be greater than pi over 2. Okay, for the reference, if we remember on how we are building our reference number, so maybe, okay, maybe it will be going from starting point here, going here, pi over 2, and then maybe going around here to make it t is 2 pi over 3, right? And we know that this reference number is from the x-axis to the short distance of that point. So this reference number will be pi over 3. Okay. But the reference number is came from pi minus pi over 3. So this cosine here we can write in terms of pi minus pi over 3. Okay. So in the quadrant 2, cosine will be a negative, right? So this is, we can say that this will be same with this. And cos pi over 3 is half, so negative is negative half. Okay. Okay, so whenever you find you need to take some relations between the trigonometric and the sines value, what you can do first is take the unit circle, okay, and imagine how you are moving a point alongside the unit circle. Okay. But if we have, for example, cosine negative pi over 3, what will happen? Cosine minus pi over 3, if we look at the reference, it will be maybe around here, maybe around here, maybe around here. Okay. So this will be t equal negative pi over 3. So what will happen here is we remember that cosine in quadrant 4 will be positive. So this is the same, just the original cos pi over 3, which is half. Okay. Because if you see, it should be around here. Because if you see here, this will be the x, that is positive x, right? So by doing this reference, okay, reference and the quadrants, I hope it can help you to at least understand the basic on trigonometry, on how to define the signs, okay, the signs, the positive, negative on cosine, sine, tangent. Okay. Okay. Any questions? Any questions? Okay. Okay. Now we are going to have a basic identity for the trigonometric. The basic identity. I think the first one here is basically the reciprocal. Okay. And also, since we have this x squared plus y squared equal 1, we can also write this in terms of the so by definitions of cos t equal x and sine t equal y. So we can have this very basic formula here. Okay, and from here we can take this and take the multiplications, and we will have 1 plus tangent squared t equals secant squared t. So we have another identity. And the same way we can get another one. This is if we are going to find the 1 over sine. We will have this, another one. Okay. Let me make another one here. Okay. If we want to draw, so let me draw this, see the circle here. This will be y, x and y axis. And we are going to So based on the unit circle, we are going to make the graph of sine. So the axis, the x-axis now is t, and the y-axis still y, so it should be having the same value. All right, let's try to draw the trigonometric value. Okay, starting with 0, and maybe pi over 2 is here, and pi is here, and 3 over 2 pi, and then 2 pi is here. So more or less, this will be the graph. Okay, notice that when I move the t, let's say I'm moving here, let's say this is t0, or maybe let's write with different color. Let's say this is t0. This will be this t0. Okay. Okay, so the sign, this is y equals sine t. So based on this unit circle, we can expand uh, the graph, making it into y and t. Okay, so we can have this. Let's say this is y equal 1 here, right? And this is negative 1. And the graph is not stopped here. It's just going every. So you still have there, still also have here, okay? But usually we are going to observe this until 2 pi period, okay? We are saying that this is, we call one period. One period means you are moving full circle based on your unit circle and back to the original positions. And that is what the period means. Okay, so it's one period. It's 2 pi. And every 2 pi, if we are having another multiplication of 2 pi, which means it will be having another full circle. Okay, every 3 times it will be 6 pi, so 3 circle. Okay. And graph of the cosine also similar, but cosine will be adjusted with sine. Okay? If you remember, sine squared t plus cos squared t is equal 1. We can say that the sine is 1 minus cos squared t, right? And cosine is also 1 minus sine squared t. Okay, so how we are dealing with this is you look here, we start from 1 0, right? And then we are going to have uh, 0 1. Okay, so from 1 0 becomes 0 1. So the x is 1 and then becomes 0. The y is 0 and then becomes 1. Okay, how many t, it's pi over 2, right? This t here. Okay, or let me write here to make it more obvious. If this is the 1, 0, this is 0, 1, and we are moving t equal pi over 2, right? So you will see that the x is changing from 1 to 0, and y is changing from 0 to 1, okay? And it's exactly at pi over 2. So when you have sine pi over 2 is equal 1, right? You have cosine pi over 2 is equal 0. So this t equal pi over 2 between sine and cosine, okay? We will see that if you want to draw the cosine, we can shift the graph pi over 2. How many times? It's pi over 2. So let's see the graph here, okay? Or let me write in another color for the cosine, okay? It's perfectly the same graph, but you're writing from here. Okay. So this other one here is our cosine t, which is you can see that it's shifted sine to the left, right? Shifted sine to the left. So shifted, okay, shifted t pi over 2. And actually, the cosine, as I mentioned, I think several times I mentioned. So the first time people introduced to a sine or sine is okay, it's so sine were introduced first. Okay, it came from the like you have this is an arrow. Okay. So back then, to name this curve here, they called something similar to sine. Okay, but I'm not sure which is the original words. But sine is, I think it's from India. And also, if you have or if you have learned some biology in your nose, okay, we call something have the curve inside in your bone. It's called sine. And if you are usually having some flu uh, because of your something stuck here, sometimes the doctors usually call you have a sinusitis, right? It's also the same word, it's the same sign. It's there's something curvy in this bone, and there's something wrong with that, and we call sinusitis. Okay, this is just for your information. And from sine, then arrive cosine. Okay, this is actually complementary of sine, in which we can see that the cosine is actually just the same graph with sine. We just shifted the graph, right? Okay, and that's how you can remember how it is. Okay. Also in the functions, okay, in the trait functions, you can also have a transformations. Okay. For example, if you have a functions 2 plus cos x, which means this is cos x shifted 2 units upwards. And if you have another functions, let's say minus cosine x, this means cosine x reflected about x-axis. So if this is the cos, then this will be the functions, the g. Okay. Okay, and if we have, let's say, the graph of sine, let's say that is our graph. Then if we have, let's say if this is 1 and the one here is, let's say 2. Start from here, going there, going there. This is sine, or 2 sine x. Okay, so reflections, and then shift it upwards, and then we have, we call this phenomenon as stretch or shrink vertically, because we can also make it shrinking, maybe become half like this. This will be y equals half sine x, right? Okay. Now from here, we can take this. Let me just wait for you if you want to take some notes. So from this, we will have another lesson for amplitude and period, and I think that will be also useful in other courses such as physics, right? You learn about this phenomenon of sine and cosine. Okay. Because from these functions uh, you can learn how the, let's say, the sound wave, or any wave, they have uh, the property of sine or cosine. Okay, but let's look at the, if we have y equals sine 2x, and we have another one is sine, it's half x. Okay, let's say we start from there. We start from these two equations. Okay, let me draw the original functions. Okay, let me draw the original functions. Let's say we have Okay, let's say that's the original sign. Okay. Let me make it into several curve. Okay. I think that will be that. Okay. And let's say this is y equals sine x. What about the sine 2x? Okay. If we look at the sine pi over 2 is 1. Okay. So this is from here to multiply with how to make it pi over 2. We need to have pi over 4, right? Okay. So the sine 2x will have different period, right? So the period becomes just pi, right? Rather than 2 pi. Okay. So if this is pi over 4, then the graph will be start from here. So it's going there. Okay. And then when pi over 2, it's become 0, right? And then there will be another one here. And then you have that. And then you have another one here. And you have that. Okay. And you can make okay. Okay. That's the y equals sine 2x. So it's become shorter, right? The periods becomes just pi. Okay, so one period here is becomes only pi. So the original period is here. It's the original period here. For the blue one, it's 2 pi. Okay. Now let's look at the other one. We have half x, sine half x. Okay. So to make it sine pi over 2, we need to take the x is pi, right? Now, if we look here, the x equal pi is here, right? This is pi. So this will be equal with sine pi over 2. So I will have this and until 2 pi here. Okay. And the period will be twice, right? Okay. Now the period, so this is y equals sine half x. Okay. Now the period will be 4 pi. Okay. Now from this phenomenon here, we can take some conclusion for sine and cosine both because both are the same, actually the same graph with different shifted period. So if we take the sine and cosine curves, if we take y, they have a sine kx, okay, and we have also y equal a cosine kx, where k is positive, okay. They both have amplitude is a, so amplitude will be this, okay. This is a. This is also amplitude, but we will just take the distance, how much is the graph is stretching, okay. So if, for example, you have like the previous one here, is 2 sine x, which means the amplitude becomes 2, okay. The a is 2, okay. And if it is half, then the amplitude is half. Okay, so that's the amplitude. Okay, and then we have the period is 2 pi over k. Okay? The period will be 2 pi over k. This is true when we are thinking the sine 2x and sine 2 half x. Right? The period here, we see that it's become 2 pi over 2, which means pi, the period. This one here, 2 pi half, this has become 4 pi. And we already look at the graph and prove that that is true. Okay. So one complete period is, if we want to take this as interval, one complete period is started from 0 until 2 pi over k. That is one period. Okay. So if you have, for example, y equal a sine 1 over 3x. So this means that the period is 2 pi divided 1 over 3. This will be 6 pi. Okay. So 0, 3 pi, and 6 pi, they will be in a 0 positions, right? This will be going up, and then at 3 pi it's 0, and then at 6 pi also 0. Okay, any questions? Okay, now this is the amplitude and period, okay, on sine and cos. Okay, now the next one is when we are shifted. Okay, we are shifted sine and cos horizontally. Okay, so sine and cosine curves. So y is a sine, okay, and then we have x minus b, and we have a cosine k, x minus b, and k is positive. Okay, again we start with amplitude. This is absolute a, and we have period is 2 pi over k, and we say horizontal shift is b. So the interval for one period, okay, it will start from b until b plus one period, okay, because we shifted b. Okay, let me go through examples for you to take the practical usage of this shifted. Okay. Let's say we have x minus pi over 3. Okay, let's start from this side. So we have, for example, okay, let's start drawing the original functions. Okay. So let's say this is pi over 2 pi, and this is 2 pi. Okay. Let's start just 2 pi period here to see how it looks like. Okay, let's say that is our original graph, the y equals sine x. So what will happen with this x minus pi over 3? Okay, one thing to check, okay? If we start from x pi over 3 minus pi over 3 is 0, right? So sine of 0 is 0. So at the pi over 3, for example, pi over 3 is maybe around here. So we can start from here, okay? And then we may start with the x minus pi over 3 equal pi over 2 to make it into sine pi over 2 to make it one value. So we can have pi over 2 plus pi over 3. This will be 6. So if this is 6, then it will be 3 pi plus 2 pi. So this will be 5 over 6 pi. So that will be around, maybe, if this is pi, then this will be maybe here, right? Yeah, you can imagine this will be maybe there. Okay. And actually, because there is no change in the amplitude and it's still the same, so this will be this very identical graph with the original function. So this will be going there, and this will be, let me take this. If this is pi, then x will be 4 over 3 pi. So 4 over 3, this is maybe around this, or maybe if this is 2 pi here, maybe here. Okay, so this is pi over 3 pi. So you just shift it 1 over 3 pi around all the point. Yeah, yeah, something like that. Okay, so you can shift the pi over 3, okay, on the positive x. Okay, so positive pi over 3. Okay, remember when you transform your functions, if you transform this x here and you have a negative sign here, which means this will be shifted pi over 3 units to the right. Okay. 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 Now, if you draw, for example, I combine x squared and then cos 6 pi x, for example. It will be a cosine. Okay. So if you look at the graph, okay, this seems complicated graph, but if you check it, okay, not really drawing really smooth, but rather roughly sketching the graph. Okay, if you check cos 6 pi, okay, cos 6 pi, okay, x, we will have some period, right? So let me draw, maybe start from cos x first. Okay, start with cos x. Okay, let me check the other. Okay. Okay. Now, if we look at this, the period will be 2 pi over 6 pi. So it will be 1 over 3 period. So which means we will have 0. Let's say we have maybe 1 over 3 here. So we will get at least like this in the graph. Okay. You can check the graph and it will be like, okay, you have the graph like that. Okay. Now we are multiplying this cos 6 pi with x squared, right? Now what you need to remember, okay, this cos has maximum value and minimum value, right? It's always positive one and negative one, right? Okay. So the graph here, we can take this as x squared and negative x squared. Okay. And precisely what happened with the graph here, okay, if you take this into our measurement and we draw some graph, okay. Okay, let me take this. Let me take this. Okay. Okay, let's say we have a x squared here. And we have another one, the negative x squared, maybe around there. Okay. And imagine the cosine becomes, they will follow the x squared and negative x squared. Okay. So it will become precisely, they are doing this. Okay, and then they are doing this. So if you look at, it's not really a good proportion, but what I want to show you is, if you look from when you zoom out the graph, you'll have something like this. Like that. Okay. Okay. So whenever you find any probably any complicated functions in terms of trigonometry, for example, okay, maybe this is not really explanatory yet because it's still in a basic formula. But when we imagine this, maybe later when you learn more about the advanced mathematics or maybe engineering mathematics, sometimes you need to imagine the functions in a simple way, and how to do that is basically, if you have this um, trigonometric like cos or sine, you know that sine and cosine, they always have the same behavior, right? And when we are dealing with the other functions, for example, this x squared here, we can know how the x squared will be, right? We have the x squared will be like this, and we know that the cosine will also have a maximum minimum value, and we can state that from here, we can state that this uh, will be this. Then we know that this will be our inequality, right? And then we can set up a little bit rough sketch, yeah, a little bit rough sketch, how the graph should be looks like. Okay. Okay. And okay, any questions first? Any questions? Okay. Um, in your chapters, I will skip several point. Tangent, cotangent, I will skip that as for now. Um, we will just focus on the sine and cosine. Also cosecant and secant, I will skip that for now. Um, and probably we can move on to the inverse, okay? But I will make it for tomorrow class, okay? So before we end, I will go to the feedback time. Okay? Feedback. Okay. So please come tomorrow for the class. Okay? We already have physical class now. Okay. Okay. Everyone ready, Jane? I think this will be quick. Okay. Not really complicated. Okay, let's start. Okay. I think we can start now. That's 3, 2, 1. I hope you remember the even, odd, and remember how the sign will be. Okay. Okay. Okay, question 2. Find the quadrants. I remember what is cosecant and secant. For 20 seconds. Okay, not really that good. Okay. Okay, good. Okay, last question. You just write the results. Okay, you write the results. Okay, 3, 2, 1. Yeah, just 2. Just y divided by x. Easy, right? Y, the answer 3 over 5, 1 over 2, 1. Okay. Okay, who is the... Oh, okay, Scarlett. Okay, congratulations. Okay, Scarlett. Okay, you have a lot meanings, right? Okay, so that's it for today, class. Hope to see you tomorrow. So please check the Google Classroom. Okay, on tomorrow. I think tomorrow night I will upload the quiz.